Hi everybody, welcome to semester B. That's why it says 7B up there. I hope you all had a wonderful winter break and that you are rested and ready to go. So this first unit that we have is all about, all about inequalities, okay? So last semester we focused heavily on equations. That's where like one thing equals exactly one other thing, right? X equals 2. In that case, 2 would be the only answer to make that statement true. With inequalities, the difference is there can be multiple answers. So you've probably heard of like x is less than 2, which that means you could put any answer in there that's less than 2 and make the statement true. Okay, so that's the big difference between inequalities and equations. All right, so first we're going to focus on solving addition inequalities. And really there's some subtraction in there too. I don't really know why they say just addition inequalities, but anyway, I didn't write that lesson. So the definition of an inequality is a statement where one expression is less than, greater than, less than or equal to, or greater than or equal to another expression. All right, and we'll do examples, so if you're like, I'm lost already, don't worry about it. Okay, we're going to get there together. So there were 4 different statements in that definition that we have symbols that represent each of those things. So less than, the symbol would look like that. Greater than looks like that. Less than or equal to, which we'll talk about the difference between those later on, looks like that. Or greater than or equal to looks like that. Not equal to is like an equal sign with a slash through it. Okay? So as we're going through the inequalities and as you go through your lesson, all of the integer rules that we learned and practiced with last semester still apply. So that goes for positive and negatives. That goes for decimals and fractions, whole numbers, mixed numbers, like doesn't matter. All the stuff we worked with last semester, we still need to take into consideration now, okay? And then you're going to write all of your answers where x comes first, or x is on the left-hand side of the inequality symbol. So, like x is less than 2. That's what that would look like, and that's how you would read that. All right, so maybe you want to write that down. X is less than 2. That's how that would read. Okay? So, let's get into some examples. So we're not only going to be solving them, we're also going to be graphing inequalities, which I like doing. I don't know why. For some reason, I think it's fun. And once you get the hang of it, it's not too bad. So, number 1, it says solve x plus 14 is less than 25. Let me see if I can get this to focus a little better. Hopefully that is a tiny bit better for you. Okay, so I'm going to treat this just like I would an equation. And if you remember from last semester, if I see addition in my equation, I need to use subtraction to solve for my variable. My goal is still to get my variable isolated or by itself. So first off, my x is already on the left-hand side of the inequality, so we're starting off really good there. And then I'm adding 14 right now. So to solve, I'm going to subtract 14 from both sides of the inequality. My inequality symbol, in this case, my less than symbol, is going to stay the same. So we're going to bring that down. 14 minus 14, well, that's 0. So those cancel, and we're left with x on the left. And then 25 minus 14 is 11. So x is less than 11. So what that tells me is that I could put any number that is less than 11 back into the original inequality, and make it true. So let's try that. Let's choose a number that is less than 11. I'm going to do 5. So if I say 5, well, 5 is less than 11, so it should work, right? So then I could say, well, now I have 5 plus 14 is less than 25. Well, 5 plus 14 is 19, and 19 is less than 25, so it works. All right, so I know that my answer is correct on that one. All right, number 2, this time we're given a graph, and you and I have not talked about graphing yet. We could talk about it, actually, with that first one. Maybe that would be good for us to do. But it says, what linear equation is shown by the graph? So let me start by doing this, actually. I'm going to graph this one just to kind of give us an example, okay? And actually, going back to our original, like the notes from the first page over here, and I'll use my orange because that's what I was graphing with. For less than or greater than symbols, when we're graphing, we're going to use an open circle. Open meaning it's not colored in. Same thing with greater than. Okay? Less than or equal to, when we're graphing, it's going to be a colored in circle because we're going to be including that number, right? Because like that or equal to sign. Okay? So those are going to come in handy when we graph. So let's practice that. And this is just a little extra. I didn't really plan on doing this, but that's okay. So x is less than 11. If I want to graph that, what I'm going to do, I'm going to set up a number line. And you can put 11 wherever. I'm just going to put it right in the middle. So then I'll have 12, 13, 14, 15, 10, 9, 8, 7, 6. Okay? So in order to graph, like I said, it's actually really easy. First off, this is a less than symbol, so I'm going to have an open circle. It's not going to be colored in because I'm not actually including the number 11. I can't put the number 11 into this and have it be true. 11 is not less than 11, right? It's equal to. So that's something we do need to consider. But whatever this number is, that's where your circle goes. So since it's just less than, I'm going to circle the 11. And then if you notice here, I have a less than symbol. Well, that less than symbol, doesn't that look just like the end of my number line? So that kind of gives you a hint of which direction should my arrow go, right? And if we're thinking x is less than 11, well, we had used 5 when I did this example, right? When I like solved it. Well, 5 is over this way, so I need my arrow to face that way too. Okay, and you can make it as long as you want. Okay, but it would look something like that. All right, so notice my less than symbol matches the arrow on my graph, and it matches the arrow on my number line, right? All of those are the same. So that's how you would graph that inequality. On number 2, this time we are given a graph, and we need to write the inequality. Okay, well, you're always going to start out with, you're always going to start out with your variable. Throughout this lesson, they use x, like pretty much the whole time. So that's what I'll do too, okay, just to be safe. So I'm going to say x, and then notice my arrow is pointing to the left, so that's what my symbol should look like it's pointing to also. It should point to the left too. And then it's an open circle, so I do not need to put the line underneath there, right? It's not less than or equal to, it's only less than. And then in this case, it's the number 4. And that's it. X is less than 4. And notice my orange arrow, right, my actual graph, is covering anything that is less than 4. Okay? And if you need more practice, always reach out to me. Right? That's not a big deal at all. Okay? I'd love to hear from you. Number 3, it says solve x minus 1/3 is less than or equal to 1/2. And this is actually number 2 on your quick check. Okay? So, just like before, well, first off, we could bring our symbol straight down if we want. okay? We're going to pretend like it's an equal sign, okay, up until we write our final answer. So right now I am subtracting 1/3. So to get rid of that, just like last semester, we have to think about the opposite operation. So what's the opposite of subtraction? Addition. So that means I need to add 1/3 to both sides in order to solve. Well, -1/3 plus 1/3, that gets me to 0, right? Those are opposites, they cancel each other out. So on the left, I'm left with my variable, and then I have is less than or equal to. And then now I need to actually solve this. So I can come over here to the side. 1/2 plus 1/3. Well, remember I talked about all those integer rules, right? When you're adding fractions, you have to have a common denominator. So a common denominator, or the least common denominator for 2 and 3 is going to be 6. And I get that just by multiplying them by each other, right? I can do times 3. Whatever I do to my denominator, I have to do to my numerator in order to keep the equation, the fraction balanced. I'm going to do the same thing over here, but this time with the 2's, right? That way, no matter what, I get 6 as my denominator. So 3 times 1 is 3. 3 times 2 is 6. 1 times 2 is 2. 3 times 2 is 6. Now that I have the common denominator, I can actually add them together. 3 plus 2 is 5. So that gives me a total of 5/6. All right, so this would be your final answer. Okay? So I hope that helps. Let me check if I have one more. Normally I only do 3 examples, but I thought we needed 4 on this lesson. This is number 3 on your quick check. Which of the following shows the graphing solution to x plus 3 is less than or equal to 7? Okay? So with that, first up, the first thing we need to do is we need to solve for x. We need x by itself. So I'll just come down here so I have more room. X plus 3 is less than or equal to 7. And I'm sorry all of these examples are all less than or equal to. You'd use the same rules with greater than as well, just going the opposite direction. So right now I'm adding 3. In order to get rid of it, I'm going to subtract 3 from both sides. 3 minus 3, that's 0, so those cancel. I'm left with x is less than or equal to, and then 7 minus 3 is 4. So that's what I'm looking for now. I'm looking for a graph that represents x is less than or equal to 4. Now, first off, all of those graphs have the filled in circle. So that doesn't help me eliminate any answers, but that's good because it's less than or equal to, meaning I could put 4 in for x and still make it true, right? Because 4 is less than or equal to 4. All right, well, whatever number this is, that determines where your graph starts. So that being said, right off the bat, I can eliminate this first one because this graph starts at 10. I can eliminate this last one because that graph starts at 10. So now I'm down to these two, okay? Both of those start at the number 4, but keep in mind, x is less than or equal to. Well, pick a number that's less than 4, right? 3. Which orange arrow is over the number 3? That's this one here, right? And remember, the end of your arrow should match your symbol, right? So this one looks like a less than symbol. There's my less than symbol. So it has to be this one here, which with mine, the way it was set up, it would have been like the third answer, or C, okay? But you got to be careful with which way those arrows are pointing. So as always, I hope that helps, and feel free to reach out to me if you need more support than that, okay?